This lesson, it's our final lesson in advanced trigonometry. And we're going to be looking at using the cosine rule to find angles in a non-right angle triangle. So let's jump right in. So the cosine rule, which is at the top of the screen now, we used a squared equals b squared plus c squared, take away 2 times b times c times cos a. And we used this last lesson to find the length of missing sides, okay? But if we look at the triangle down here, we know all the sides. We know one's 5 meters, 7 meters, and 8 meters. And the missing fact of this triangle is the angle, okay? So we can also use this cosine rule to find the size of a missing angle once we know once we know the length of all the sides of the triangle, okay? So for the cosine rule, again, just like all the past sine and cosine rules, they're for non-right angle triangles. And it's when you are missing an angle, but you know all 3 sides. Okay, so that's when we use this cosine rule. It's when there's a non-right angle triangle, we are missing one angle and we know the length of all 3 of the sides. Okay, currently this formula is set up to help us find a missing length. Okay, so if we want to use it to find an angle, we're going to have to rearrange it slightly. Okay, and you will need to, you were given this formula in an exam, but you won't be given the rearranged version, so make sure to practice this, okay? So if we start off with our original formula, we've got a squared equals b squared plus c squared, take away 2bc cos of a. Okay, so before we put any substituting values in, we're just going to rearrange this so we can use it to solve for an angle, okay? So first things first, I want to take this minus 2bc over to the other side of the equation. So the way I'm going to do that, I'm going to add minus 2bc, I'm just going to add 2bc cos a to both sides of the equation, okay? And that gives me 2bc cos a plus a squared, and that is equal to b squared plus c squared, okay? So remember, we're trying to get cos a on its own here, okay? So the next thing I'm going to do is I'm going to take away a squared from both sides of this equation. So that leaves me with 2bc cos a is equal to b squared plus c squared, take away a squared, okay? Now the final thing I need to do, again, I'm trying to get cos a on its own, so I need to get rid of this 2bc. Because I'm multiplying cos a by 2bc, I need to divide both sides by 2bc. And that will leave me with cos a on the left-hand side. It looks like a bit like a H. Let's get rid of that. And then b squared plus c squared minus a squared. And this is going to be divided by 2bc. Okay? So this formula here is going to be the starting point for all the questions we're going to do this lesson, okay? But to finish off this, remember, if we've got cos of an angle, to find out what the angle is, we need to inverse cos the other side of the equation, okay? So the final answer to this would actually be a equals cos minus 1, or cos inverse. And then in the brackets, we would have solved what all this was, okay? But we use this formula here to find a missing angle, okay? And we've got this by rearranging the original cosine formula, okay? And then you do the inverse of cos to find out your answers once you've substituted all your sides in, okay? So let's answer a question using this formula. So you can see up top now, I've changed the formula, so it's the rearranged version, so it's going to be nice and useful for us, okay? Now, the most important about finding missing angles with the cosine rule is that you have to label your triangle correctly, okay? It's not like when we're finding a missing side. It was quite easy to get that right. But when we're finding a missing angle with a cosine rule, we have to make sure we label up our triangle correctly. Okay, so on the side here, I need to find out what angle A is. So angle A is going to be the angle we're trying to find. So in this case, it's the x. So angle A is equal to x. Now, this is the important one. We need to correctly identify side A, and that's going to be opposite angle A. So side A is going to be 7 meters. And then after this now, it doesn't matter which one B or C is, okay? B and C can be either or. So I'm just going to have B as 8. I'm going to have C as 5 meters, okay? So I've labeled up my triangle now, okay? And now I've done that, I can just plug these numbers into this formula, and then I can find out the missing angle, okay? So to substitute in now, so cos angle A, we had that to be x equals b squared, well, that was 8, so then we got 8 squared, plus c squared was 5, 8 squared plus 20, oh, not 25, 5 squared. Take away a was 7 squared, okay? And then we're going to divide that by 2 times b times c. So 2 times, well, b was 8, and c was 5. So 2 times 8 times 5. And if you solved this in your calculator, you would find that cos x is equal to 41 over 80, which is roughly equal to 0.5125. Okay? So the final step now we know that cos of x are these values. We need to do the inverse of cos to solve for the final part. Okay, so x equals cos minus 1. If you want to be completely accurate without rounding decimal places, I would use the fraction. Okay, but if you do use the decimal version of the answer, make sure you round to at least 4 decimal places. Okay, so x is inverse cos of 41 over 80. That would give us a value of x equals 59.17 degrees. Okay, that's our final answer for our missing angle using the cosine rule. Okay, let's have a look at another example. So again, we got a triangle. We know all 3 sides, but we're trying to find the missing angle x here. So first things first, we're just going to label up our triangle. So we're trying to find angle A, side B, and side C. Okay. Well, angle A is going to be the angle we're trying to find. So that's going to be x. Side A is opposite angle A. So that's going to be 10. And then side B, I go around clockwise. So I'm going to have B is 4 meters. And then C will be 11 meters. Okay, but it doesn't matter which one B or C is. You have to make sure you get side A right. Okay. So here we go again. We're going to use the formula. So cos of A, well, A we're taking to be x. B squared, B is 4. C squared, C is 11. So 11 squared. A is 10. So A squared is 10 squared. Divided by 2 times B was 4 and C was 11. So cos of x, if you solved all that in your calculator, you would end up with 37 over 88. And if you turn that into a decimal, you would get 0.42045 recurring, okay? So now we know that cos of x is 37 over 8. We need to do inverse of cos. So x equals cos minus 1 of 37 over 8, 88. And if you pressed equals in your calculator, then you would find that x was equal to 65.14 degrees. Okay, just like that. So again, just recapping this now, the most important part is to make sure that angle A is the angle you're trying to find, but side A is opposite that missing angle that we're trying to find. Okay, Now let's do one more example. So one more triangle now, and let's label up this triangle. Let's make sure we're doing the right things now. So angle A, side B, and side C. So angle A is the angle we're trying to find. That's going to be X. Side A, well, that's going to be opposite angle A. So A is 20 meters. B, C, I go clockwise, so I'm going to call B is 9 meters. And then C will be 16 meters. Okay. Again, we're just going to use the formula now. So cos angle A was X. B squared, B was 9. So 9 squared plus C squared. C was 16, so 16 squared. A 20, so A squared is 20 squared. All of that over 2 times BC, so 2 times 9 times 16. If you pressed equals in your calculator to solve that side of the equation, you would get minus 63 over 288, okay? And I'm just going to leave this as a fraction, just so it's nice and easy to solve the inverse of cos. But before we do that, let's have a quick look at the angle of this triangle, okay? So actually, this angle here is bigger than 90 degrees, okay? Now, when we did the sine rule, we had to be careful of that, because when we used our formula, we weren't able to tell if it was an angle larger than 90 degrees or not, because it always gave us the angle less than 90 degrees or acute angles. So just bear that in mind, and let's see if the same thing happens with this formula, okay? So we know cos of X is minus 63 over 288. So that means X is going to be inverse cos of minus 63 over 288. Let's just draw those 8s better. And that gives us an answer of X equals 102.64 degrees. And that's perfect. So 102 is an angle bigger than 90 degrees. We can see this angle is bigger than 90 degrees. So we don't have to change anything when we use the cosine rule for finding angles bigger than 90 degrees. Okay. So that's nice. That's nice to bear in mind for this rule. Okay. So that's 3 examples for you. Let's have a look at the main task now. Okay. So here we go. We've got 5 questions for you, and we've also got the challenge question as well. Now, I've given you the original cosine rule formula up here. That's because I want you to have a go at rearranging this so you can get the equation for finding missing angles, okay? So make sure you practice rearranging this equation, because you're going to have to do that in the exam, okay? So pause the video and have a go at these 5 questions, okay? Best of luck. Okay, so here are the answers. Very well done if you got them right. And for the challenge question, if you worked out all 3 angles, I feel very sorry for you, but hopefully you found out the smallest angle was 50.13. And a way to find the smallest angle in a triangle is it is always going to be the angle opposite the shortest side. Okay, so very well done if you got those right. And let's move on to the checking question. So here's the final checking question of the lesson. Okay. We are being asked to find the size of angle DAB. Okay, so that angle, so it's angle A between points D and B. Okay, so that is this point here. So we're trying to find this missing angle here. Okay. Now you may have to use another rule from another lesson to answer this question. Okay, so have a little think back to the last couple of lessons. What other rule may you need to use to solve this question? Okay. So pause the video and give it a good go. All right, best of luck. Okay, so hopefully you gave it a good go. So the first thing, the problem you should have discovered is that in order to answer this question, we needed to find the length of this side here. So we're trying to find the length of BD, okay? Because we need to use this. We need to use this to use the cosine rule to find out angle X, okay? What rule could we have used to use this to answer this question? Well, hopefully you realize we had to use the sine rule, where side A over sine angle A was equal to side B over sine of angle, capital B, sine of angle B, okay? So we had to use this to find the missing length of BD, okay? So to use this rule, so we had BD divided by sine. The opposite angle to BD was 43. So sine of 43. And that should be equal to, what other sides and angles do we know? Well, we know 9.2 centimeters, and its opposite angle is 88 degrees. So we know that 9.2 over sine 88, they should be equal to each other. So to rearrange this equation, we have to do BD equals, and we have to multiply both sides by sine 43. That would have got a BD on its own, so that would also give us on the other side sine 43 multiplied by 9.2 over sine 88. Okay, and if you pressed equals on your calculator to two decimal places, not B, BD, you would have found that to two decimal places, BD was equal to 6.28 centimeters. Okay, so now we know this. We know that the length of this side here is 6.28 centimeters. Okay, don't know what that's points there. Now we can use the cosine rule to find size of angle X. Let's just call it X here, okay? Which is, but we're actually trying to find DAB, but we're going to call it angle X, okay? So hopefully you remembered the rule for finding out the missing angle. When we know three sides, you have to rearrange the cosine rule. I'm going to write down the rearranged version here. So we've got cos of X, sorry, cos of A, and that is equal to B squared plus C squared, take away A squared, and that is over 2BC, okay? Now let's identify the different parts of this triangle. So I'm going to use a different color to help us out with this. So let's use blue. So we need to find angle A, side B, and side C. So angle A is X, obviously. So I'm going to call that A. Side A is opposite. So that's going to be, sorry, X. Side A is opposite angle A, and that's the new side we found. So that's going to be 6.28. And then B is C. I go clockwise. We're going to call 4.6B, and we'll call 5.4C. So 4.6 and 5.4. Okay. So if we substitute these values into our equation, red pen. So we've got cos of X is equal, B was 4.6, so 4.6 squared. C was 5.4 plus 5.4 squared. A squared was 6.28 minus 6.28. All of that divided by 2 times B was 4.6 times C was 5.4. Okay, and if you pressed equal on your calculator, I turned this into a decimal because it was a very tricky fraction, but you should have found that cos of X was equal to 0.219. That was to 3 decimal places. We have to do the inverse of cos, so X equals inverse cos of 0.219. Therefore, X was equal to 77.35 degrees. Okay, and that is your final answer for the question. Okay, so we found out the size of angle DAB is 77.35 degrees. So very well done if you got that right. There was a lot of steps going on there using all of the rules we've learned, or using most of the rules we've learned in the last couple of lessons. Brilliant. So good work, guys, and we'll see you next lesson. Bye now.